All right, my friends, if you're thinking that this is a lot like the ratio test, then you are absolutely right. So we get to say the sum of all the a sub n's converges absolutely if this expression is greater than 1. We get to say that the sum of all the a sub n's diverges. Oh, goodness gracious. Is less than 1. The sum of all the a sub n's diverges if you get something greater than 1 for this expression. And the ratio test is inconclusive if we get exactly 1. Sorry for that mistake there. Anyway. All right, my friends. Example 2, we'll do 2 problems just to make sure that you've had enough practice. One thing that people get a little worried about when we throw all these tests out there is how will I know when to use which test? And I hope if you look at example 2, parts A and B, there's something screaming, take the nth root of me. And so I hope that makes sense, that, it's really, this is your tip off that maybe root test is a good idea for these. So anyway, so I'll go ahead and do part A with you, and then you can make sure you could do part B for independent practice. So getting started, we're going to basically do the limit as n approaches infinity. Now, what I'm about to write, I typically skip this step. But it is kind of nice to see just kind of the prompt to the work for the first problem. So I'll go ahead and show that. So what I'm writing right now is typically my first step for a root test problem. So we're just going to go ahead and do nth root and then absolute value, and then you put a sub n in there, so. Now, what are those absolute value marks doing? Not much, to be honest with you. They're really just making sure that no matter what type of root we're taking, we're not taking the root of some negative number, causing imaginary results or any insanity. So, and in this case, the absolute value marks honestly are doing absolutely nothing. But I think I'll just leave them just for fun. So the nth root and the nth power would undo each other. And so we'd be left with the limit as n approaches infinity of redundant absolute value marks of n over 2n plus 1. And then I'll go ahead and let n approach infinity. I'm going to use horizontal asymptote rules to figure this out. Degree 1, leading coefficient over leading coefficient. And we get 1/2. So what does that tell us? It tells us that if we were to expand this thing out far enough, we'd find out at the tail end, the terms basically just become 1/2, and you're adding up infinitely many, they don't become 1/2, I'm sorry. The series becomes geometric with a common ratio of 1/2. So what does a geometric with a common ratio of 1/2 do? Yeah, it converges. And it also converges absolutely. How do I know? Because if your common ratio or if all those terms were negative, you'd still have them going to 0 fast enough. So that means that this thing, which it wasn't geometric all the time. It just became geometric at the tail end. So we would say that it converges absolutely by the root test. There we go. Okay, my friends, go ahead and see what you'll do with part B. Go ahead and practice the steps, even if a lot of people can look at part B and figure out the answer maybe in a different way. But go ahead and practice root test on it, see how it goes, and check in with me in the next video. This is our last one for 8-6. Do your best.